Okay, so I did number 10, and it says calculate the magnitude and direction of the Coulomb force on each of the 3 charges shown in the figure. Okay, so here you can see I redrew the diagram and changed these to meters and those to coulombs. And then I labeled my positives, and I have the equation. So then I have to use the equation we learned to find the forces on each of the coulombs. So for the force number 1, it's of this proton onto this proton. So that so the equation is going to be 9 times 10 to the 9 meters squared per coulomb squared times 6 times 10 to the negative 6 coulombs times 1.5 times 10 to the negative 6 coulomb. And then you're going to divide by the distance squared, so that's going to be divided by 0.03 meters squared, and you get 90 newtons. For the second force, we're going to do we do the middle proton and the electron, so that's going to be 9 times 10 to the 9th meters squared per coulomb squared times 1.5 times 10 to the negative 6 coulombs times, this is going to be absolute, so it's going to be the absolute value, so it's positive 2. It's 2 times 10 to the negative 6 coulombs all over 0.02 meters squared. And you plug that into the calculator, you get 67.5 newtons. And then now you find the third force, which is going to be this proton onto that electron, and you're going to do 9 times 10 to the 9th newtons meters squared per coulomb squared times 6 times 10 to the negative 6 coulombs times 2 times 10 to the negative 6 coulombs all over, and you add the two distances, 0.05 meters squared, and you get 43.2 newtons. So now you need to find the net forces. So for the net force on the this proton, you're going to do, so the force of the 6 coulomb is equal to the first force we found, which is up here, minus the second one we found, so minus F2, and you're going to, so it's going to be 90 minus 67.5, and you get, sorry I did this wrong, so it's going to be actually the F3 minus F1, so that's going to be 43.2 minus 90, and you get around negative 46.7 newtons. And you know it's negative because it's the total force is going left. For the second force on 1.5, it's going to be the first force plus the second force, and which is 90 plus 67.5. So you do 90 plus 67.5, and you're going to get 157.5 newtons. And then for the negative 2 coulombs, you have to do the second force plus the first force. So second plus the third force. So that would be 67.5 plus 43.2. And you get 110.7 newtons. So these are all the total forces, net forces.